Okay, in this video I'd like to run through some samples of some slightly more complicated derivatives and really try to help you get a plan for how to attack these guys. So first of all, at this point, if you haven't watched the videos on what the product rule and quotient rule and chain rule and etc. are, then you should stop right now and go back and watch those videos, because this is really, I'm assuming that you understand the basic, how to take a basic derivative, okay? So, in this case, so you look at this f of x right here, notice what happens is, we have a fairly complicated function, not real ugly, but you got x squared times sine x times tangent x. And so, because we got some things multiplied together, and they all involve x, it seems to me like the product rule will be involved here. So the technique that I'm trying to teach right now is really getting a plan of attack when you have a function that's more than just a simple derivative. And so basically the question you want to ask is, what is the rule that's going to get me started? It's going to organize how I do everything. And so in this case, because I'm multiplying things together, or let's take a different look, because I'm not dividing anything, I know I'm not going to use the quotient rule. There's no reason to even discuss the quotient rule. And so my first thought is it's got to be the product rule, because I have things multiplied together, right? Now the issue is that I have three things multiplied together, and the product rule only handles two things at a time, because we know the product rule is if y equals u times v, that means y prime equals u prime v plus v prime u. Right? That's the basic product rule. You got to take the derivative of the first thing multiplied by the second thing plus the derivative of the second thing times multiplied by the first thing. But there's only talking about two things there, right? So that's why these are kind of complicated. So what you have to do is you have to decide from the beginning, you're just going to assign a u and a v. So I'm going to say, for example, I'm going to take the yellow stuff, and I'm going to call all of that u, and I'm going to take the green stuff and call that v. So I just decided that this is what I'm going to do to find this derivative. I'm going to use the product rule, and the x squared sine x is my u, and the tangent x is my v. So then that means that I know that f prime of x, the derivative of f, would have to be u prime v plus v prime u. And in case you haven't picked this up on earlier videos, when I say u prime, I really mean du dx in this case, right? Okay? It's just a quicker way to write it. Okay, so now, I know, so this is right here that is kind of my guiding light. This tells me I need to know the derivative of u, I need to know what v is, which I know what that is, that's green, so actually I can take care of that right now. I'll put a little green spot there, that's green. And we know that that's yellow. No, not that. Not that. I'll rewrite that. We know that that's u, okay? This is v. So I know in this answer, I'm going to have tangent x times something plus something else times u, which would be x squared sine x, okay? So that was my u, and that is my v, okay? But what I'm missing right now is a u prime for the first one and a v prime for the second one. So I'm going to go find those things. Now I think it's useful to go off to the side here and just do your derivative that you know you need. I need to know the derivative of x squared sine x. Well, when I look at that, when I go to take a derivative of that, I quickly realize I'm going to have to use the product rule again. So not to confuse myself with other letters, so I'll just we'll call this my m and this is my n. And then I know to find u prime, I'm going to need m prime n plus n prime m. Right? And then I could go even here another step and say, okay, what is m prime? Well, that's 2x. What's n prime? That's cosine x. So then down here, I'm going to write m prime, which is 2x, times n, which is sine x, plus n prime, which is cosine x, times m, which is x squared. Oops, I'll put that up front. Okay, run out of colors here, but let's try to work this. So blue would be x squared, which ended up right down there, right? Because that was my m. And we'll say pink is the sine x, which ended up right there and right there. Don't have any other color options, bummer. How about purple? We got m prime, which is right there, which is right there, which is right there. And we got n prime, which is right there, which is right there. Okay? So now we know what n prime, u prime is. We need to know what v prime is. Well, v prime, that's pretty easy. That's just the derivative of tangent, which would be what? Secant squared x. Okay? So now, I'm going to go back over here and think, what was I doing? I need to know what u prime is. That's going to go right there. And where is u prime? That's this right here. So I'm going to write in there 2x sine x plus x squared cosine x. And then I also need v prime to go right there. Well, v prime is just secant squared x. Okay, so now I've filled in all my stuff, and I'm going to go ahead and simplify if I can. Let's see, this would be 2x sine x tangent x plus x squared. Now when I multiply tangent by cosine, remember the tangent's sine over cosine, so the cosines will cancel out, so this would just be x squared sine x. And then secant squared, there's nothing really to simplify there, so that would just be x squared sine x secant squared x. And that would be my derivative of f. Okay, so again, the key here is to ask yourself at the beginning, what is the rule that's going to get me started? It's going to organize how and when I take a derivative. So let's look at another example over here, this g of x. So notice there is a division involved here. So my initial thought is I'm going to use the quotient rule to kind of drive my plan. So let's call this u and this v. And then I'll go off to the right here and say u prime. Well, to find u prime, we have to use the product rule, right? And again, you could go over here and find the derivative of two players, or you can do it on the fly. I mean, the more comfortable you get with this, the more you should be able to do the product rule for the simpler ones on the fly. So for example, here I need to take the derivative of the first, which is x squared. What's the derivative of x squared? That's 2x times the second, that's e to the 3x, plus the derivative of the second. Well, what's the derivative of e to the 3x? That's e to the 3x times the derivative of 3x, which would be 3, and then times x squared. So in case you missed that, let's call this, well, let's just use some colors. So x squared ended up being right here, and that's the derivative of x squared, right? And there's e to the 3x, that's e to the 3x, and that's the derivative of e to the 3x. Okay? So then likewise, what's v prime? That's going to be equal to negative sine x, because that's what the derivative of cosine x is. And so now I'm ready to take the derivative, because I think I've got all the players now that I need. Well, we know if this is my u and v, I know that I'm going to have low, which is v, d high, minus high, d low, all over low squared. Okay? So then now I just got to fill in the stuff. So what I need a v, well, I know that v is cosine x. I need a u prime, which is this guy right here. So I'm going to write 2x e to the 3x plus x squared e to the 3x. And then I'm going to subtract from that a u. Well, u is just x squared e to the 3x times v prime, which would be negative sine x, so I'll just make that positive and put a sine x there. Now on the bottom I need v squared, which would just be cosine squared. So again, I went off to the side and found my derivatives that I needed, came back and plugged them into the formula. Now we just need to simplify this a little bit, so let's simplify it. Let's see, we got cosine, we got 2x e to the 3x cosine x plus x squared e to the 3x cosine x plus x squared e to the 3x sine x. And all of that is over cosine squared. Okay? Now we're almost tempted to add those two together because they have the same x squared and e to the 3x, but because one has a cosine and the other has a sine, there's really nothing we can do. We can't combine those. So, okay? So that's a complicated product rule, a complicated quotient rule. Let me do a chain rule that has a lot of stuff going on with it. So let's say we have h of x is equal to, let's see, e to the sine x squared. That looks like a good one. Maybe yeah, well, that's good for now. Okay, so now this is obviously not a quotient rule or product rule. Well, hopefully it's obvious because there's nothing being multiplied. Everything is inside something else. This is not sine times x squared, it's sine of x squared, and this is not e times sine, it's e to the sine. So everything has, all the different functions that we see here are inside of each other. So this is a composite function. So we think the chain rule is my governing rule because there is no product or quotient rule thing here. So when I've got a complicated chain rule, I need to think about all the layers. And I think several people have asked me, how do you know when to stop and start doing chain rules? And I'll talk about that. So the first thing you want to do is figure out the layers. So I'm going to go over to the side here and say layers. What are the layers? Well, the outside layer, which means if you think order of operations, it's the last thing I would do to x. So it might be easier to go from the inside. I mean, the first thing I'm going to do to the x is square it, right? Then after that, I'd take the sine of that. And then after that, it's e to the power of. So the first layer, the outside layer, is e to the. And notice I'm just leaving that blank, but I just want to give you the kind of the shape of the outside layer. It's e raised to something. The next layer is sine of something. And then the third layer is something squared. And then, of course, the fourth layer is x. So basically, I need to know, when do I get down to x? Okay? Yeah, like that. Okay, so then what I'm going to do when I employ the quotient rule, when I employ the chain rule, I'm just going to begin taking derivatives of layers, and you multiply each successive derivative of the layer. So the first thing I'm going to take a derivative is e to the. Now, when I'm doing e to the, what's the derivative of e to the? It's e to the. There's no, remember with the exponential rule, it's natural log of the base, natural log of the base times the original equation, original expression, right? But remember, natural log of e would be just 1. So the derivative of e to the is just e to the. So my first layer, my first layer is e to the. Now, e to the what? Well, it's the same thing it was in the first equation. It's sine of x squared. So that's the first layer. So now I've taken care of this layer. Don't go back and look at it again. You're done with it. So now the next thing I have to take the derivative is the next layer, which is sine of something. Well, what's the derivative of sine of something? The derivative of sine of something is cosine of something. Well, cosine of what? Well, whatever it was in the original equation. That would be x squared. Now we've taken care of that guy. Now the third step, the third layer, was something squared. How do you find the derivative of something squared? That's 2 times the something to the first power. Well, what was the something? Same thing it was in the first equation, x. And then finally, the inside layer is x. What's the derivative of x? Well, the derivative of x is dx dx, which is just 1. So we don't need to write it. We don't need to write that one either. So once we get down to finding the derivative of x, which is the innermost layer here, then we know to stop. Then we just got to go back and try to organize this a little bit, possibly simplify. There's not much to do here. Probably put the 2x out front, e to the sine x squared times cosine x squared. Okay, let me do another example of that. F of x equals, let's say, 2 plus e to the 5x. Let's make it fun. X squared e to the 5x raised to the 4th power. That's good for now. Okay, so once again, we think about this. It's not really anything multiplied together or divided. It's just something inside of something. Now, hold on. Actually, I noticed there is a something being multiplied together here, right? So it seems like we're going to have to go to the product rule at some point, but I can't really get to this until I've taken care of this outside layer. So that's an important thing to remember. So the guiding rule here is going to be the chain rule. I've got to take care of the chain rule because the outside thing, this to the 4th power, is kind of protecting everything inside. So the chain rule is going to drive my decision. So I'm going to start over here and write my layers down. What are the layers? The outside layer is to the 4th. Now the inside layer is 2 plus something squared times e to the 5 something, right? So that's a complicated layer that we're going to have to deal with. But and so we're going to actually, so that kind of ends this original kind of setup. So once we get down to here, we're going to have to use another rule. So let's go ahead and start with that. So when I go ahead and take the derivative of this, the derivative of the outside is something to the 4th power. So that would be 4 times something to the 3rd power. Okay? Well, what is the something? The same thing it was in the original equation. That would be 2 plus x squared e to the 5x. But now I have to take the derivative of this next layer here. Now, this next layer here is a problem. So I'm going to go over here and I'm going to rewrite this as, well, the derivative of 2 is not a problem. That's just going to be 0. So I'm not going to worry about that. But what I need to know is what's the derivative of x squared e to the 5x, right? Well, because it's being multiplied together, I have to use the product rule. So I'm going to do my little u and my v here. And I'm looking for u prime v plus v prime u. Go over to the side here and find out what is u prime. That's 2x. What is v prime? That's e to the 5x times 5. Because the outside layer is e to the, so I just take the derivative of e to the, which is e to the. And then I take the derivative of the inside, which is 5x. The derivative of 5x is 5. And then the derivative of x, of course, is dx dx, which is 1. Okay? So then down here, what I have is u prime, which is 2x, times v, which is e to the 5x, plus v prime u, so that would be 5x squared e to the 5x. Okay? So then when I go back over here, the derivative of this thing, derivative of 2, of course, is 0, but the derivative of this thing here is going to be 2x e to the 5x plus 5x squared e to the 5x. Right? And that would be the end of our... Now, how do we know that we stopped there? Because we found the derivative. This right here, we employed the chain rule when we were taking this derivative, right? Right over here, we had the chain rule. So this chain rule kicked out the derivative of x squared is 2x dx dx, which is just 1. The derivative of e to the 5x is e to the 5x times 5 dx dx, which is just 1. So we got down to that dx dx and knew that's what told us to stop. Okay? So this is a start out with a chain rule, having to employ a product rule in the middle of it. Okay? I think I'll do one more example here. So we got f of x is equal to, let's say, tangent to the 4th e to the x squared. Get some crazy stuff going on here. So once again, this is the chain rule that seems to be a composite within a composite within a composite. So I'm going to sort out my layers over here. There's no multiplication division going on. Everything's inside each other. So the first layer is something to the 4th. All right, that's that little bit right there. The next layer is tangent. Whoops. Next layer is tangent of something. The next layer is e to the something. The next layer after that is something squared, and then finally x. Right? So let's begin the process. F prime of x. I need to know what the derivative of something to the 4th is. That would be 4 times something to the 3rd. And what is the something? Tangent of e to the x squared. Now if you wanted to, you could just put that 3 back right there, like we had it. Okay? But now we've taken care of the outside layer. Next layer, tangent of something. How do I find the derivative of tangent? Well, the derivative of tangent is secant squared of something, right? Well, what is the something? Same thing it was in the original equation, e to the x squared. Then I took care of that layer. The next layer is e to the something. What's the derivative of e to the something? E to the something. What is the something? X squared, just like it was in the original. Took care of that. Next layer is something squared. How do I find the derivative of something squared? We take 2 times the something to the 1st power. And then finally, what's the derivative of x? The derivative of x is dx dx, which is just 1, so we don't bother writing it, and we're done. Click, click. Now we just got to clean up a little bit. We got this multiplied by 2x over here and multiplied by 4 over there, so we certainly can bring those together to get 8x. And we'll throw the e to the x squared out front here, and then we just throw the rest of the stuff in here. And that would be my derivative. Okay, hopefully this is helpful when you start tackling some of those more complicated derivatives.